Next problem, if customers arrive at a counter in accordance with a Python process with a mean rate of 3 per minute, find the probability that the interval between two consecutive arrivals is more than 1 minute. Then we have to find between 1 minute and 2 minutes. Another one is 4 minutes or less. So here we are going to use the Poisson process. So x of t is a random process. After that, it may be a Poisson process means p of x of t. P of x of t, p of x of t equal to n. This term equal to e power minus lambda t whole power n divided by n factorial, where n equal to 0, 1, 2, and so on terms. So here we use lambda is a parameter, t is denoted as time. So x of t is a random variable with the time t. Here Poisson process is depend on the parameter lambda and the time t. So p of x of t, consider here x of t as n. So this term equal to e power minus lambda t whole power n divided by n factorial is Poisson process. Here I mention in question mean rate of 3 per minute. So that we put here lambda equal to 3. These are the given terms. We have to find the probability that the interval between two consecutive arrival is more than 1 minute. This is subdivision 1. We have to find interval between. So the time is here mentioned more than 1 minute. So that we are going to use one property on Poisson process, that is the interval between the consecutive occurrence of a Poisson process with the parameter lambda has an exponential distribution with a mean 1 by lambda. So here we know that already Poisson distribution is p of x equal to x equal to e power minus lambda into lambda power x divided by x factorial, where x equal to 0, 1, 2 and so on terms. But exponential distribution is f of x equal to lambda into e power minus lambda x, where x greater than 0 and lambda greater than 0. Suppose the function f of x may be 0, any other limit exists. So the function is f of x equal to lambda into e power minus lambda x. Here we are going to use while the two consecutive occurrence is mentioned in our question, so that we use property 4 of Poisson process. So here we consider the function f of x as lambda into e power minus lambda x and lambda equal to 3. So that here 3 into e power minus 3x, where x greater than 0 and lambda greater than 0. So we have to find subdivision 1, probability of t greater than 1, because here we are going to find interval between the time is more than 1 minute mentioned. So that we are here find probability of t greater than 1. That is equal to using the exponential distribution. So we get here probability of t greater than 1 means integral general is minus infinity to infinity f of t dt. Here t is greater than 1 is mentioned so that we can use here p of t greater than 1 equal to 3 into integral 1 to infinity e power minus 3t dt using the function f of x equal to 3 into e power minus 3x. Particularly here t is greater than 1. So that here limit is lower limit is 1, upper limit is infinitive based on the given definition f of x equal to 3 into e power minus 3x and x is greater than 0. So here t greater than 1 means 1 to infinity. The function f of t is 3 into e power minus 3t. So this term equal to integral 1 to infinity 3 into e power minus 3t dt means 3 into e power minus 3t divided by 3 because the integral of e power minus 3x dx is minus e power minus 3x whole divided by 3. So that here we get 3 into e power minus 3t divided by minus 3. So lower limit is 1 and upper limit is infinity. So 3 and 3 get cancelled. So minus of upper limit is replace the t with the infinitive. So e power minus infinitive minus lower limit is 1. So e power minus 3 into 1 we get e power minus 3. And that is integral e power minus 3t dt 3 into e power minus 3t dt limit is 1 to infinitive means 3 into e power minus 3t divided by minus 3 limit is 1 to infinitive. So 3 and 3 get cancelled. So we get minus of e power minus 3t limit is 1 to infinitive. So we substitute the upper limit and lower limit as t. So minus t into e power minus infinitive minus e power minus 3 into 1. So we get minus e power minus infinity value is 0 minus e power minus 3. So we get e power minus 3. So this is our answer. Next we have to find the time between 1 to 2. So we have to find the probability of 1 less than t less than 2, that is equal to integral 1 to 2 function is 3 into e power minus 3t dt. Here x is a random variable with a continuous random variable. Here t is continuous random variable. So that we get integration of 1 to 2 3 into e power minus 3t dt is 3 into e power minus 3t divided by minus 3. Limit is 1 to 2. So 3 and 3 denominator 3 get cancelled. We get minus of upper limit is substitute for t. So e power minus 3t. So e power minus 3 into 2 equal to e power minus 6 minus lower limit. Replace the t with the lower limit 1. So we get e power minus 3. So totally multiply with the minus e power minus 3 minus e power minus 6. Using calculator we can answer e power minus 3 and e power minus 6 values and subtract the required answer. We get the required answer. So subdivision 3 is probability of t less than or equal to 4. Required is the probability of the interval is more than 4. So that we get here a probability of t less than or equal to 4. So 4 minutes or less is required. Probability to find the interval between two consecutive arrival is 4 minutes or less. So that we consider here probability of t less than or equal to 4. That is equal to 4 is an upper limit. Lower limit is referred with the given term. Given is condition x is greater than 0 or t is greater than 0. So that the lower limit is 0 to 4. Function is 3 into e power minus 3t. So integrate and substitute the upper limit and lower limit, and simplifying we get the required result. Thank you.